So yeah, today's talk is machine learning for fun and or evil. And yeah, let's go through it. So first, let's talk about what is machine learning. And simply said, machine learning is teaching machines to recognize patterns. We want to learn some function or some process or some task through past experience. Mathematically, we want to look at some set A and some set B and approximate the function that maps A to B. And mathematics is boring, so let's go through a quick little fun toy example. Let's suppose we've got a list of cats and a corresponding list of labels that denotes whether a cat is a happy cat or a sad cat. And we want to figure out how can we tell if a cat is happy or sad. So we look through our data and we know, and we have some mathemagic in the background, and it's a bit complicated, but we're just going to ignore it for now because that's boring stuff. And it looks through this stuff and it says, oh, hey, I've looked through all of these patterns and I figured out that if a cat is purring, there's a 98% chance it's a happy cat. And so we learn the function to determine whether a cat is happy or not from our experience. And that is super cool, but there are some problems with doing that. And that is that machine learning can be really difficult, right? We need to prepare our data, we need to clean our data, then we need to spend time and resources and compute power and all that actually on the training. And after all of that, we're not even guaranteed like a 100% solution. There's still some margin of error and it's just not perfect. So why do we even bother with it? And the reason for that is that machine learning allows us to approximate any function or process, or basically any function or process, even if we don't know what that process is. So if we just have a set A and a set B, and we have no idea what links them, we can just throw it in a server and wait a couple weeks or days or however long it takes to train, and it will give us some function that says, well, yeah, I can figure out how this works. And instead of considering the mathematics, I suggest we just look at it as a black box, where we choose a technique based off of whatever cool YouTube video I watched last week, download the code for it, set it to train, and wait for it to transform our input into our expected output. Machine learning is magic that allows us to do things that we just can't do through normal hard coding traditional methods. And now we get to the important part. How do we do it? Because yeah, it's great that we can do all of this stuff, but we haven't gone into the details yet. So what exactly do we do? And the first thing with any machine learning project that we need to talk about is the data, right? The hardest part is just getting good data. We need data we need a lot of it, but not too much or else it's going to take forever to train through it. We need it to be consistent so it's not missing too many things, or it has all the same fields, but we want it to have some variation so that we can generalize. Same thing with noise. We don't want too much noise, but we don't want too little noise. And the list just goes on and on and on and on and on. And getting data is really hard and it's really boring to clean up. So we are going to skip all of that because this is for fun. And what we do is we're going to find someone else who has gone through all of this process. And we're going to go to a website like Kaggle, and we're just going to download a nice clean data set for us. Alternatively, if it's something hyper-specific, you can just go find yourself some data scientist who will look through it and clean it for you. But yeah, once we have this neat data, what do we do with it, right? It's good and all to have it, but where are we going with it? And for that, let's talk about tools we can use, right? For most ML projects, we want to use Python, which is objectively the best programming language. If any of you disagree, you can come fight me after work. Python's super easy to learn, even for people who aren't programmers or computer scientists or technically minded at all. There's an old joke that Python is just English that compiles. And yeah, it's basically that. And it has a library for literally everything. If you want to do machine learning, there's plenty of libraries for that. If you want to get tweets from Twitter, there's libraries for that. If you want to automatically generate procedural cat images, there's a library for that. And it's great. And I've been speaking a bit about libraries, so let's talk specifically which libraries do we use. And for most people, if you're getting started out, I recommend the following libraries. The first one is scikit-learn or sklearn, and that one is super, super simple. It's got functions for all the basic stuff: regression, classification, neural networks. and it's really easy to use, and I'll demonstrate that a bit later on. Then if you need something a bit more powerful and more complex, you'll look at something like Keras, which is also quite simple, but lets you do a lot more interesting stuff. And finally, honorable mention to a library called NLTK, or the Natural Language Toolkit, which is my favorite one because it lets you work with text data, and I'm very fond of doing that in my own side projects. So all these libraries have built-in implementations and functions for various existing techniques. So for instance, if we want to make a neural network, which is all the rage these days, we just say sklearn.neuralnetwork.mlp classifier, and we import that, and boom, we don't have to do any of the maths ourselves or any of the code ourselves. We just say, here's my X, here's my Y, please figure it out for me. And that is really great. It means that even somebody who doesn't have any background in maths or in computer science, within a few lines, you can have an up and running model, which is really great. And so here I've got a little demo training a neural network in 3 lines of code. You just import your classifier. You have your X data set, your Y data set. And here's the important part. You just say classifier equals MLP classifier. Boom, you've got a neural network. Classifier.fit XY. Suddenly it's trained. Super, super easy. And finally, when we want to actually apply this model, we just say classifier.predict, and we pass it a different X. And that's it. You've done your entire machine learning project, well, the hard part of it at least, in basically 3 lines. And that's great fun. So let's talk about using ML for fun, right? We can use it for a lot of cool stuff. Snapchat uses it for filters, so they can add dog ears to you or cat ears or whatever. You can use it to create art and music. I'm very fond of this. In fact, I've made a project before where it works, where I procedurally generate music using machine learning. These days, it's been used to play games like classical chess, but also newer stuff like StarCraft and Dota. And last week, I came across a machine learning algorithm that can write and tell stories. They just prompted, tell me a story, and it popped out 5 paragraphs of completely consistent story, which is really, really wild for a computer program to do. Like, we've managed to make computers be creative. But we can also use it for evil, right? These days, we always hear about Facebook using our data without us knowing, and they can use machine learning for this. They can track you anonymously and then use the machine learning to associate that anonymous data with your actual Facebook account without you knowing or actually consenting. And I don't know about you guys, but that's really, really creepy. Second bullet point here is one I learned from a friend of mine. Banks can use machine learning to try and influence your spending habits. So they'll use it to pop up like a prompt in the app being like, hey, do you want to get a credit card? And they use machine learning to find out the bands of people who might be liable to get a credit card, but not wealthy enough to pay it off completely. And that way they make sure you're indebted to them on a permanent basis, and they just have a constant flow of revenue from you. Very, very creepy. And the last one I've got here is sentiment analysis, where we can look through people's emails or tweets and whatnot, and just see how do they feel about certain things, and we can monitor their opinions. And that has a lot of potential for evil. If, I don't know, my boss looks through my emails and he finds out, oh no, I don't like the company that much, and he can just fire me. I do like the company, Lucky, don't be scared. But yeah, and I've got a sentiment analysis program in my demo, which I really hope works. Oh, it's in the same browser. So this tool here is called Google Colab. It lets you run your Python stuff on the cloud. It's completely free, and it's really easy to share with it. And so here we've got a little block that installs our libraries. I've already done that. We download our data, which I've also prepared. Let's just wait for it to run because it takes a little second. Now we do training. For this one, I've used NLTK. And NLTK, to train, you prep your data, but I found somebody else who did that for me, and it's at this nice blog link. And all you really do is say classifier equals naive Bayes classifier dot train, and you give it the data. Black box. I have no idea how naive Bayes works. I learned it once and it went right out the other ear, and I've forgotten it now. But you just click train, and it takes a second or two. Make sure to choose a nice small data set for this, and it spits out an accuracy. Here our accuracy is 70%. which is not so great, but considering I trained this in like a second and on very little data, we don't really expect much better. If you give it more time and more data, it will just get better and better and better. And you can get scarily accurate these days. And then for the next part of the demo, I've got like, I fetch tweets in real time. Please don't steal my credentials. And let's do a quick search. Let's see what people have been saying about SCOM, for example, right? Or do we expect positive or negative things about that? So we fetched our 100 tweets, and now we're just going to score them quickly with this code block. And I know I'm rushing through this, but I'll make the code available for you guys later. And we can see that only 42% of the stuff that people say about SCOM is classified as positive, which means people don't really like SCOM that much. Surprise, surprise, everybody. And yeah, like this took me a weekend to put together. It's super easy to get started, and I recommend everybody goes and tries it. And yeah, have fun.